Here's the hot water tablet. It went from 1.31 down to 1.14. Interesting. That's a loss of 0.16. This is down to 1.18. That's a loss of 0.12. So that lost less mass. And the cold temperature TUM tablet went from 1.32, drum roll please, to 1.26. It only lost 0.06. So I'll summarize these results in a second, but it looks like indeed a higher temperature results in a quicker reaction rate. All right. So indeed, reaction rate is proportional to temperature. This is a mathematical relationship. Higher temperature, higher reaction rate. Lower temperature, lower reaction rate. So the question is, how does this relate to the atomic theory of matter? Well, if you remember from the last lab where we varied concentration and investigated the effect of concentration on reaction rate, if we use the theory of atoms, if we assume the theory of atoms is correct, and we look at reactions as being dependent on collisions between things we call atoms. If there are more collisions in a certain amount of time, say 2 minutes, then there'll be more, then the reaction will have gone farther. And so here, what's temperature? What's this temperature business? So again, you have to take a step back and think of what temperature is. And physicists really played a big role in this in the middle 1800s, late 1800s. And they've determined what temperature is. And temperature actually is a measurement of atomic motion. So if something's hotter, it means the atoms are moving or vibrating or shaking more vigorously, faster. If things are colder, that means the atoms are not moving as quickly. And so if we take a look at our just simple model of acetic acid molecules swimming around in solution, here's our 2 TUMS tablet, but instead of varying concentration, I have 5 acetic acid molecules here. Our concentration is the same. I have 5 acetic acid molecules. I have 5 acetic acid molecules here. What we're seeing is that if these are moving faster relative to these cold ones, in any moment of time, in any span of time, there'll be more collisions with this TUM than over here. And so this, in conclusion, this lab is also consistent with the atomic theory of matter. Both these labs, the concentration and temperature, kind of, and again, it's not foolproof, it's just nice evidence or a nice kind of argument to say, hey, atoms are a thing, they probably exist, and therefore, the first 3 chapters of this course, we can rest assured the data and the ideas that we came up with are sound.